So here we go over our practice problems on aromatic nomenclature. As we've said in the past, one of the tricky parts of aromatic nomenclature is the fact that many of these compounds actually can have more than one name that's acceptable under the IUPAC system. And that's immediately true from our first question here. While this looks like a relatively straightforward example, and it should be, an aromatic ring with just a methyl group and a NH2 group, the reality is this is a good example of a compound that has many different names. Now we know that the CH3 group here is referred to as a methyl, and the NH2 group, if we call that as a substituent, we would use the name amino. However, we also know that if we have just an aromatic ring with a methyl, that we can use the name toluene for that. Similarly, the NH2 group on an aromatic ring also has a common name that we've learned. That of aniline. So a number of different directions we can go with this name. The second piece is the relationship between the two substituents. We can see that this is a 1-3 relationship, which we also know is referred to as meta. So we could sort of at this point use any of these combinations that use 1 and 3, use meta, use the names of the substituents methyl and amino, or use the more complex common names toluene or aniline. So any of those directions work in this case. Typically, we'd probably use the amino group as our root and therefore use toluene. And if we do that, and if we're going to call this as a aniline derivative, then we'd name aniline. That means by default, the carbon containing the nitrogen would be carbon 1. That would make the carbon with the methyl group carbon 3. Because we're using aniline as the parent name here, we don't actually need the 1 in front of aniline. The 1 is assumed, and so we can just call this (3-methyl aniline). Had we gone the other way, this could have been 3-amino-toluene. But also remember the meta, or M, is our abbreviation for meta, are in many cases more common than using the numbers when we have two substituents on the aromatic ring. And so in either one of these cases, we could have used an M or meta instead of the 3. And probably our most commonly used name for this compound would be M-methyl aniline. But this first one is a good example of how complicated aromatic nomenclature can get especially for what looks like such a simple compound. And again, that's because of the number of common names that exist, plus the fact that for di-substitute aromatics, we have both the numbering system as well as the ortho-meta-para possibilities. All right, now number 2, also di-substituted, but probably a little bit more straightforward. The aldehyde, we've seen before, and we know that that group gets named as benzaldehyde. The ethyl doesn't really have a common name when it's the substituent on the aromatic ring, so we'd use benzaldehyde as our root here. That makes the carbon that's attached to the aldehyde carbon 1. And regardless of which way we number it, the ethyl group is going to be at carbon 4. Again, we don't need a number to indicate where the aldehyde is because it's assumed to be on carbon 1. And then we can refer to this as 4-ethyl benzaldehyde, or more commonly, P or para-ethyl benzaldehyde. Again, remember, using P or para in this case is correct. Using a 4 there would also be correct, but you cannot use both. All right, number 3, we have a situation where the aromatic ring is actually going to be counted as a substituent. And we're going to number this based on the alkene, and we're going to go around this ring that's larger than the aromatic ring in counterclockwise fashion to give us then the lowest possible number for our substituent. Given that the aromatic ring is unsubstituted, we refer to it as a phenyl group. So 3-phenyl. We then have a 7-membered ring containing an alkene. So 3-phenyl cycloheptene. Again, we don't need a 1 for the alkene because we know that from how we number cycloalkenes that alkene is by definition assumed to be on carbon 1. Part 4, the group we're going to use as the basis for our name is going to be the alcohol or the hydroxyl group. So that means we have carbon 1 here. And then we should notice that this ring is symmetric, so it doesn't matter which direction we number the ring in. We're going to get the same numbers going in both directions. So with the alcohol as part of the parent, that's known as a phenol. Now, because we have more than 2 substituents in this example, we can no longer use ortho, meta, or para. We can only use numbers. Ortho, meta, and para only apply when there are exactly 2 substituents on the aromatic ring. So we have 2 nitro groups, 1 at 3, 1 at 5, and so this becomes 3,5 dinitrophenol. Could you have named this where the hydroxyl group would also be a substituent, so using hydroxy instead of phenol? The answer is yes, but in general for aromatic nomenclature, if we can include one of the substituents in with the parent name, that's something we generally do. All right, question 5, you can see we have a whole bunch of substituents. In fact, they're on every carbon. And again, we're going to pick the one we would to use as the parent name. that being the carboxylic acid. And so that gives us a name of benzoic acid as our parent. Now, either direction we go, left or right, is going to give us substituents on 2, 3, 4, 5, and 6. So it's just a matter at this point of deciding which direction we need to go. And if we go to the left towards the chlorine, our next substituent is chloro. However, if we go to the right, we get methoxy, which alphabetically comes after chloro. And so that tells us we're going to go in this direction. So with the large number of substituents here, it may help us to just make a list. 2 chloro, 3 bromo, 4 fluoro, 5 ethyl, and 6 methoxy. In order to get our name, then, we're just going to put those substituents in alphabetical order. So coming first is bromine, so 3 bromo, then 2 chloro, next comes E for ethyl, so 5 ethyl, we've run out of room, so we continue down to the next line for 4 fluoro, 6 methoxy, benzoic acid. Alright, in the case of number 6, we've got this alcohol group, so we can name this as a phenol. And then numbering this one around to the left, we get our 2 methyl groups at carbons 2 and 4. We choose to go that direction. Same reason we've been doing throughout every other functional group. It gets us to the first substituent faster, giving us 2,4-dimethylphenol. This last one, we actually don't have a common name to use as our parent, so it's just going to be benzene. And we'll erase that because I've not left myself with enough room here. So parent name, again, is benzene. But of the 4 groups we have a pentyl, we have a tert-butyl, a chlorine, and we have an isopropyl. And as with cycloalkanes, we can start our numbering anywhere that we want. And so we can make any of the positions with a substituent carbon 1. So how do we pick? We pick the position with the substituent that comes first alphabetically, which is our tert-butyl group. And we go around to the right here. So we end up with 1, 1 tert butyl, 4 chloro, 5 isopropyl, 2 pentyl benzene.